today's speaker or the resource person for this particular webinar, as you are seeing, is Pradeepta Mishra. He is the head of AI and ML at L&T Infotech. Earlier, he was heading the data science team at Lymbyc, which got acquired by L&T Infotech. And they have a specific product called Lenny, which he and his team has built. And maybe some of you who are not familiar with this product, please do look up at LTI website to see what Lenny does. And Pradeepta, if you see, do connect with him in the LinkedIn. He will also talk about himself. He is a very young 40 under 40 data scientist awardee by Analytics India magazine for consistently for a couple of years. He is a very, very enthusiastic researcher, come writer, come innovator, and known as a thought leader in this space. He has about 5 books, and some of them have been even translated to multiple languages like Chinese on because of popular demands. He has about 5 patents. We are fortunate to have Pradeepta as a board of studies member for all our RAISE programs. And he has been actively associated with us in teaching, learning, as well as guiding some of the projects with us in career transitions of few of our participants. And we are really thankful for Pradeepta to take his time off today and present to you how, from his perspective, what are the challenges, what are the life cycle, what are the tools, what are the plus points of actually running an end-to-end AI project in the real sense. So over to you, Pradeepta, and looking forward to a great session as usual.
Hello everyone, good evening. So today we are going to talk about what is AI project and why it is called AI project and how it is typically different from traditional software development projects, and what are the nuances of the AI project, what are the challenges of AI project, and what is the right approach ideally we should take to handle the AI projects. So this is what we are going to talk about. Now, why it is typically different from classical software development projects is that there is a AI/ML intervention which is required at least one stage in this project lifecycle. So most of the problem statements that we see today, or the like solutions that we see today, it has at one or more than one layers of like intelligence which is already enabled. Now you can think about, let's take you are using WhatsApp and you are typing a text to your friend, right? It's predicting the next word, and it's providing an automatic suggestion to you that this is the next word you may be interested in typing it, right? So that's nothing but intervention of a bidirectional LSTM model in behind the scene, which tells you that what is the next word you would be typing given the background that you have already typed historically, either to that person or you have used the keyboard to type maybe certain other people, right? So basically behind the scene, it creates a vocabulary and it tries to suggest based on your typing history what should be the next word you are going to type, right? So that's one. The other applications, even you can see, let's take the fitness applications that you see today, right? It tells you that, okay, if you complete another 100 steps, you will be hitting, let's take the American Heart Association's criteria of, let's take 25 active minutes a day or 30 active minutes a day, something like that. So how this engine predicts, because it tracks your movement, it tracks your steps, and it builds a recommendation, custom recommendation to you. Now, this is nothing but the intervention of some kind of ML and DL models behind the scene, right? Similarly, when we look at or when we surf or go through various blogs online, so we can find some of the advertisements. Now, earlier the advertisement spaces were occupied with a lot of, you can say, random advertisements. Now, if you are reading one educational blog or educational website, you can see some kind of applications or some kind of advertisements which are contextual in nature, which means the blog you are reading, suppose you are reading a health blog, the gymming advertisement you can see, or gymming instruments advertisement you can see on the advertisement section, right? That's nothing but the contextual advertisement, which means it's a project about how to identify the context. The user is reading something, and the contextual advertisement should be appearing on that particular page, right? So any project that needs some kind of ML, which is machine learning, or DL, which is deep learning models, or any other kind of learning models. Could be like, let's take a reinforcement learning layers, right? So if you are playing chessboard on your mobile application, it tries to increase the difficulty levels because that's reinforcement learning. Because as you play, it increases the difficulty level because you are getting acclimatized with the difficulty level. Now it should increase the difficulty level to a higher level, right? So any project that involves some kind of a learning elements can be called as an AI project, right? That's one kind of definition. The other kind of a definition could be any project where some kind of a decision engine need to be built, right? So when somebody is applying for a personal loan or a home loan, so there is a calculator. The calculator makes a prediction. So how the calculator makes a prediction? The calculator makes a prediction based on, so that's a decisioning engine, right? Whether you are eligible for a loan or you are not eligible for a loan, it asks you certain parameters, demographic parameters, or income, demographic, all those parameters. So keeping into account or taking into account all those parameters, it gives you a prediction whether you are eligible for that or you are not eligible for that, right? So it's just a calculator, which is like maybe it could be used in the banking industry. But if you want to use the same decisioning engine, let's take a real estate, right? Suppose a real estate agent wants to understand the intent of a particular customer, whether he is seriously interested in buying a property or he is just exploring, right? So if you want to do that kind of prediction, that's another kind of decisioning engine. So any project wherever you can find a decisioning engine, you can, and that project can be qualified as an AI project, right? Similarly, some kind of projects where the process needs to be, or the process is feeded by a prediction engine, right? So decisioning engine or classification engine or prediction engine, if that kind of algorithmic intervention is required, that you can call as an AI project. In today's world, with a lot of digitalization and all, so definitely you would want certain components of your project to be automated. While building these automatic pipelines, you can create maybe various AI projects around that, right? And only thing is you have to associate the right project to a right learning algorithm or what kind of algorithm it can solve, right? Or you can break the problem into like smaller sub problems or sub components, which will help you in deciding the overall goal or achieving the overall goal. Okay. So here, that's why what is AI project is, it's about like any kind of a project, a software development project where algorithmic intervention is required, where decisioning engine is required, where intervention of any learning algorithm is required. Now that is called an AI project. Okay. Now, if we look at the life cycle of AI project, it starts with an overall challenge or a problem, right? So let's look at a problem statement. Could be a very generic problem statement. It could be how do we recognize, let's take fake reviews, right? So we can see various product reviews online. Now, what is a genuine product review and what is a fake product review? Even if the fake product review is using a product ID and it tells you that this is or looks like it's a genuine product review, right? Can a AI/ML engine identify what is the difference between a fake product review versus, like, let's take a genuine product review, right? That's an overall challenge. But how do you scope it out, right? So challenge is at a one statement or one liner statement, which is at a very high level. But to break the problem statement and scope out, now in this way, I mean, it looks like a classification problem, right? So you can just say, hey, I can just train a classifier to identify the fake product. It's a binary classifier, whether it is a fake product or it's not a fake product, right? But how do you build this overall solution? How do you build this overall solution? It's not that easy. And it's not just a classifier. You can just train it. So many, you can see naive, or I can say naive solutions, or maybe you can, uh, like, it's a very naive approach to handle, like just to jump to the conclusion that, okay, use a classifier to train the fake product review identification. That's not the way it should be done. So you have to scope out. So what is scope out? Is it already labeled whether it is fake or not fake? Can someone look at this and have a label like it is a fake product or it's not a fake product? Can someone just tell, or is there any way to arriving at a label? If not, is there an automated labeling exercise that can be done? Is there any process where I can feed the text of that review? It should be able to tell us some flags. What are those flags? The flags could be, let's say, grammatical errors. If there is a grammatical error, probably that's a genuine review, because genuine customers, they may not be able to write proper English. But sometimes when you find the error-free sentences could be generated by a bot. Now, can we identify any particular patterns or any particular sophistication of writing English? Now, that's another kind of problem statement. It doesn't look like simple a fake product, like identification of a fake review or not review, right? So you have to look at, and this, like, out of this problem, another problem came up to understand the, or to scale or to grade the maturity of English knowledge, right? If someone is writing a very naive way, someone is writing very sophisticated way, sophisticated hi-fi English, then is there any way to classify the text, right? So based on the English sophistication and scale it. Now that becomes another project out of the overall project, right? Now based on that grading, you can assign the scales, and based on the scale, you can say that, okay, this looks like fake, this looks like genuine. Now once you have this interim level on top of it, then you can train the algo probably, right? But it doesn't look like that simple. Now the second thing here is, when somebody is writing those let's take reviews, somebody is putting symbols like smiley symbols or some kind of dancing symbols, or like making faces, so some kind of emojis you can see in the text window, right? So when you do a standard text cleanup for training a classifier, a machine learning or a deep learning classifier, you will be probably deleting or removing those kind of emojis. But what is required is conversion of these emojis to the text. Now this becomes another project where you can train a separate engine which takes the emojis or GIFs or small emojis or smileys or any kind of special symbols and convert it to text, because these emojis and GIFs cannot be converted to text or cannot be trained. So you need to translate it to text. Now this becomes your third project to solve this classifier, right? So like this, what can be done within this project, what cannot be done. So you have to scope it out, because in order to give a foolproof solution, you need to look at all those angles, right? It's just to give an example of two projects or two sub projects you can draw out of this. However, there can be many other such things, right? So could be like abbreviations. Some people, they are just using abbreviations in the text. Now you need an expanded form of it in order to train your algo, right? So you need another solution, or you need another program which will take into consideration the abbreviation forms or short forms and expand to convert it to expanded form, so that you can use the text, expanded text, in your classification, text classification system, right? So these are like 2 3 sub projects you can see. And that's how, to give a foolproof solution, you have to scope it out, and you have to build the solution from scratch, right? After scoping it out, there are certain things. For example, somebody has put an image with a review, then of course the image could be the product image, right? Or it could be broken product image. So you have to interpret. Now that turns out to be a deep learning project, which is an image recognition or image captioning project, where you have to look at the image and translate it. So if it is, let's take a small bottle, and the bottle is broken or the cap is broken, and somebody has taken a photograph and put it in the review, then your engine should be able to translate it that this is a damaged product which was being delivered to the customer, right? So either manually do it or have an algorithm to do that. That's how your project scope will keep on expanding, because you want to deliver a complete solution to the end customer, right? So what you can do, what could be, if we could do it, and it would be better, but what kind of timeline you are looking at, what are the different softwares, what are the different solutions or tools, programs, machines you need, you have to scope it out. If you have if you want to do something like a image processing, probably you would need a GPU or access to cloud, where you can run a deep learning model, kind of convolutional neural networks, to train the image to text captioning, right? Similarly, once you scope it out, then you have to go to the design phase. In the design phase, you have to establish the linkages between the solution and the components of the software where the solution will reside, how the communication will happen. And usually the communication happens using RESTful APIs. But what kind of RESTful APIs? Where if this project involves some kind of ML or DL models, where do I store it? How do I store it? What should be the version controlling system here? Who will access this? How they will access it? Is there any restrictions? Is there any data privacy? Is there any personalized identifiable information, PII information, which need to be masked? So what kind of things that are required? So the entire designing has to happen in the design phase itself. Then you will proceed with the development. So 90% of the design work should be done. 90% of the design work should be completed before you proceed towards the development step, right? And 10% should be iterative. You can change it, or you can find some better method or better approach. You could always change it. However, most of the design, most of the development, before starting the development, most of your design work should be completed. Now, once the design work is completed, then you go for development. And once you develop it in the deployment pipeline, you have to check the CI/CD pipeline, whether it should be fitting to the CI/CD pipeline or not. Because in a traditional software development platform, of course, CI/CD it is compatible with the CI/CD. However, the MLDL systems, right? You should not overtrain your models. You should not kill the machines by overtraining the models again and again, because it will not produce a different result. If you run it once, whatever result you got, if you run it twice or thrice, you will not get a different result. You will probably get the similar result. Then what's the point of having this CI/CD? There is no point in running it again and again, right? So you have to take a call. If it produces different results, it makes sense. If it doesn't produce different result, then there is no point in running it. So you can just run it once and you can use it for inferencing purpose again and again. Then comes the QA or the testing phase. So the testing phase, what will happen here is like what you have deployed, whether it is working or not, whether it is working end to end or not, you can identify. And once it is tested and approved, you can go to like live. So once it is live, you have to monitor whether this is perfectly working or not working. If it is, if it requires some kind of fine tuning, right? So what are the model output metrics that are being used here? And the final step here is, if there is an improvement or scope for improvement, improving this particular solution or this particular project that is being delivered, if it can be improved further. If it can be improved further, yes, what are the different areas where it can be improved further, right? So looking at the current state, so what happens, and typically, if you look at here, so first is problem statement or context establishment. Next is searching for the right algorithm and searching for the tools and frameworks. So this is what is like, what is the ideal state? This is what is required. However, today, how a typical data scientist approaches the problem is that the reverse. First, they will jump into Keras, PyTorch, scikit-learn, machine learning, deep learning, you talk about, let's take the same problem, identification of fake product reviews or developing a AI system to monitor the fake product reviews, right? First, you ask them what is the problem or what is the approach to solve this. I'll use a Keras model to train it and classify it, right? So that's why I mean the approach currently people usually take is one, two, three. First, they'll jump into the tools, the frameworks. Then, okay, random forest did not work. I will just go ahead with the naive Bayes. First, you have to evaluate what kind of algorithm, how it works, how exactly the computation happens behind the scene. So these are APIs. If you look at scikit-learn, Keras, PyTorch, any machine learning or deep learning algorithms, they are designed in such a way that any kind of numeric or integer metrics you will provide, it will give you some output to you, right? But how to make sense of that particular output, whether it is the right algorithm for that or not. There are so many classifiers out there. What kind of classifier? What type of classifier? Where do I use it? That's very, very important, which typically we do not provide a lot of attention today. Okay, I tried random forest, it did not work. I tried XGBoost, it did not work. I tried a CNN, it did not work. And I tried a naive Bayes, it works. First of all, you need to know where naive Bayes is useful, where it is not useful. Is it compatible with the problem I'm solving, right? The next thing here is the problem or context understanding. The problem statement can be broken down into 5 or 6 different other problems, associated problems. And each problem, you can handle it using applying different kinds of machine learning models. If it is involved with a image, you may have to involve a CNN model there. First, to convert the image to text. Next, if it is a text which is involved in the problem, you have to make sense of the text. Text cleanup, text analysis, and making sense of text. That can be generating a summary of it, that can be generating some features from the text, that can be further utilized in other pipelines. How to make sense of the text, the meaning of the text, the context of the text should be extracted. If it is a structured data, now the structured data can be handled in multiple ways. It's not just data processing. Maybe I have 400 attributes, I have a million records database, but all the 400 features, are they required for solving this particular problem? I may need like 10 or 20 features for this particular project. So that's about carefully analyzing the problem statement. And basically that's something called analytics translation, right? So textbook description of a problem statement to analytical problem statement. That translation is very important. If we convert the problem statement from a single line of text and frame it mathematically or analytically, this is what is required. This is what I would like to know. Then you can think of what is available and what is not available. Then what is available as in the data perspective, what types of data involved in this project, then based on the data type, your algorithmic selection will happen. Your further approaches need to be defined. And finally, you should look at, if I want to do this, what kind of tools or frameworks are compatible to this, right? It should ideally be from the left to right, not from right to left. Okay, that's the current state of things that people usually do, and mostly, I mean, this is what it should be followed. Okay, so when we look at the challenges of various AI projects, first is, I mean, thinking about tools and programming first. That's a mistake. So ideally, we should not look at that, right? So what we should look at is like data quality, whether it is relevant or not in this problem statement, right? So data quality, labeling issues, if there is no label, that is the same example of a fake product review. If there is no label, fake, not fake, fake, not fake, label is already there, straight away you go for a classifier. There is no point in doing this kind of analysis, but that is rarely available. So it's a data labeling issue. You cannot have like unstructured data where the labeling is not done, right? So you need to first label it. And these are data quality or labeling issues. In structured data, most of the data you will find are like having garbages. Some of the columns having null values. Some of the columns having some like different kinds of format, right? Which you need to translate it to a proper format. The second important challenge here is limited understanding about the data and computation. Now, if I have a string data of like 5 or 10 different columns, and I'll convert it to one hot encoded vectors versus level encoded vectors, what kind of impact it will have on the overall accuracy? What kind of impact it will have on the computations? That also I need to be clear about, right? I can't just put any numeric data in the algo and I will expect the output to be great. I would expect the predictions to be great. That's not right. So you have to see what input I'm providing to the algo, what output I am seeing from that, whether it is making sense or not, right? Next word is like next challenge here is use of Jazzy tools without understanding how it works. That's another problem or another very serious challenge here, right? I can use, let's take a PyTorch transformer. First of all, you need to understand how the transformer works. Without understanding how it works, I will just apply transformer, generate predictions, and hey, I just did that and was how it works. If I change the input sequence a bit, does my output change? If yes, why? Right? What are the reasons why it changed? So we failed to explain that. So even if you look at the various Jazzy algorithms today, in most of the scenarios, the real thing is your linear regression, logistic regression, and time series forecasting and clustering. These are the four algorithms which are used in 80% of the projects mostly. Those Jazzy algorithms, they're fine, right? But it is not scalable. You will not be able to explain it. And because these simpler algorithms, they always are the right choice, right? So if you have to explain the behavior of a model to someone, go for simpler models, right? So that's why always focus on simplistic rules or simpler models to explain and involve those in the AI project so that you can explain it later on to someone. Okay. Similarly, you have various other computing tools doing probably the same thing, right? If you want to build a text classifier, you can use scikit-learn, you could use TensorFlow, you could use Keras, you could use PyTorch. Same data, all four different frameworks, and it produces similar result. Output, accuracy, exactly same. Performance, exactly same. But why there is an alternative of four? Which one to choose? Why I should choose one over the others, right? That's also very important. So that's why when you have alternate or competing tools, always you should be in a position to benchmark them, right? Run it, do the experiment. The best way to know or the best way to take a decision is you do it yourself, right? So do it yourself, hands on, do the practice, look at the results and understand. Okay, but this is important. Benchmarking of existing tools and frameworks is very much important, right? And the first thing that you are looking at, thinking tools and program first, that should be the last thing to do. First, framing the problem, identifying the algorithms that can solve this, looking at data types, data pre-processing techniques, methods. These are important things, right? And finally, it is also very important to look at the ethics, bias, and explainability of those models, because we have various projects from different industries where you have a regulatory compliance need to explain the predictions, to explain the biasness of the models. The first question would be: is your model unbiased? If no, what degree of bias is there? Can I compute the bias percentages? What extent it is biased? What is the acceptable limit of the biasness? Right? So these are typical challenges which you definitely find when you actually work on any kind of AI projects. Yeah. So first thing here is, in while scoping it out, those four important things: explore all angles of the problem. Like exactly the fake product review system, you will have to look at different kinds or forms of review that the user can provide. For each type, it could be different. Like it could be like dramatically something different, which means the customer may have recorded a voice snippet and would have posted the voice snippet. So you have to listen to that audio clip or video clip, extract it to text, and then you can do the analysis, right? Similarly, assess the feasibility. What kind of angles that you're exploring in your scoping phase all should be feasible. If something is not feasible, you call it out that this is not feasible. Now, once you have all the feasibility list, you do a prioritization based on the complexity, based on the exploration of various other methods, and also do a selection: what to do, when to do, and what should the sequence of it. And finally, you have to look at the tangible outcomes that you have to define for each of the selections, right? Now, once you do the selection, then you can go for the build phase. In the build phase, you have to spend almost 50-60% of your time on your basic data analysis to interpret and understand the data, right? So in the build phase, yeah. So in the after doing this basic data analysis, you will be looking at the modeling scenario, right? Whether it can be modeled, it can't be modeled, how many records you have, what is the dimensionality of the data, is it required to reduce the dimensions, or is it okay to proceed with the dimensions, right? So then you do a data preparation, then you develop script for the model. Now, once the script is ready, then you can send it for training. Once the training is done, evaluate how good it is. Now, once it is identified, okay, this is good to go, then you can go ahead with publishing the model for integrations. Now you'll go to next phase. You can go to the testing or the QA phase, where you will integrate the trained model on your software development lifecycle or software development process and do the testing end to end. This is your deployment. In the deployment stage, it's important because your model is working not in silos, it's working in an ecosystem. The ecosystem means your training data comes from the applications. Now, your training data, once new records are ingested to your database, there has to be a trigger to trigger the pre-processing pipeline. Your pre-processing, once it is completed, it should first check whether retraining is required or not. If retraining is required, your model training process should start, right? So while deploying, you have to look at how the data is coming to the database. Is it a streaming data, which is real-time data? Is it a batch data? Is it like some kind of continuous sync? So you have to look at, and for different kinds of data, you have to decide the deployment. If it is real time, certainly in the real time, you cannot produce the predictions. So what you have to do, you can only trigger the data cleanup, validation, and store it in the database, right? So first, you have to do in the deployment step itself, you have to perform a code review, whether all the required things are in place or not. Once it is there, then go ahead with the unit testing framework. Then decide if you have to take different paths for real-time data and batch data separately, or it can be processed together. Once it is established, then you have to look at the scalability aspect of it. Now, can I scale it up by adding more clusters, running it in different clusters? Then comes your CI/CD pipeline and making the solution scalable, right? And once it is done, if you are setting it up on a cloud, you have to do all the trigger setups. When to trigger what? So you have to run a cron job over there. Okay. Now, once it is deployed, then you have to look at the or establish the monitoring framework. The monitoring framework, if it is on a cloud, on-premise, or it is a hybrid. If it is like hybrid, sometimes your training can happen on-premise, your deployment can happen on cloud. If it is completely cloud, you are doing end-to-end things on the cloud, which means your cloud billing also may get impacted. So first of all, you have to set the metrics to train the models, watch the billing, watch the performance of the model, then do the fine tuning if it is required. And once it is delivered, then you can stop the training process because unnecessarily it will increase the billing, right? So if you are doing everything online or cloud, then you have to set the metrics, right? If my model accuracy is touching almost like 95%, and I'm at epoch of 10, then there is no need to further retrain. Even if you have given 100 epochs, there is no need to retrain or continue training. So it should stop the training where it is reaching the desired level of accuracy. It should not keep training. So stop overtraining of models, right? So monitoring mechanism is very important. And the most important thing out of all those five things is that performance of the model. You can define the performance. The performance of a predictive model can be defined by looking at the set matrices. Those matrices can be scalability, or reliability, stability, accuracy of those models, right? So once you set those matrices, you can watch the performance. So there are various cloud watch or monitoring systems on different provided by different cloud providers, and you can just set this and continuously analyze this. If there is a need to improve it, right? Or always look for feedback, how to improve it, and look for feedback, how to incorporate the feedback. Yeah, that's all. So just right in time. Okay, any questions you have?
Yeah, so there is a question which is coming is that how the testing of machine learning model is different from traditional software testing at the deployment stage.
Right, very good question. So testing of ML models, it's different from software testing. So in software testing, we typically do a A/B testing, right? So and the outcomes are quite defined, and you have finite test cases. However, in a predictive uh, modeling scenario, right? So what is the input to the predictive model? It is one data point. And if I have let's take a fake product review system, right? And if I get a new product review, I have to identify and predict whether it is fake or not fake, right? So if I get 10 reviews, I have to make prediction for 10 times. But the question is, are those 10 units that or 10 texts or 10 reviews that I'm receiving, are these 10 things are 10 test cases? No. What you have to see here is in a ML system testing is that whether the end-to-end pipeline is working or not. In the modeling step, you have 5 different steps. You have a data input step. Is it reading the latest data or not? That's one checkpoint. So you have to define the test cases like that. So if I'm reading the data, new data, for making prediction whether the data is read properly or not. Data is read properly, but pre-processing is failing or not. Pre-processing is okay, successful. Okay. Now, if pre-processing done, whether if I'm passing this data to the model object, is it generating prediction or not? It is generating prediction, and the prediction generated is rendered to your platform. It can be a website, it can be your mobile app, it can be any other software platform. So your data read from the application to delivery of the predictive model outcome to any platform. If that end-to-end thing is completed, your testing process is done. No need to test individual data points, right? That's how it is different. However, in a traditional software development platform, you have to develop each and every use case. So, for example, if I pass this parameter with a special character, whether it is passing or failing, something like that. But here you don't have to do that, right? So that's why there is a clear difference between ML testing versus software testing. Second question, for coding purpose, we can use Python? Yes. So for coding purpose, there are different programming languages. You have Spark, you have Scala, you have Python, R, Ruby on Rails, you have SAS. There are various other softwares which are available. So you have to choose a platform which is quite flexible. It should be able, you should be able to integrate with the different other systems, platforms, right? So that's why Python is quite flexible, right? So ideally, you should choose for coding purpose, you should use Python. CI/CD is absolutely required for ML projects. Continuous integration is not required. Continuous development is required, because here continuous development means retraining the model from the new data, right? So not with the every single data point addition to the database, you have to take a build and retrain the model. It's not required, but you have to do it in a frequent interval. Could be like once in a month or every week, or maybe once in 2 weeks. You have to retrain the model. Your model should be a representative of most recent data rather than the old data. Continuous integration, of course, once the integration points are established, you don't have to take care of integrations. But continuous development of ML model, yeah, that you have to ensure. It has to happen. On an average, how long would an AI project run? See, AI project run, it depends on the complexity of the problem that you are solving. If your problem statement is like this product review example, it is leading towards image processing, audio processing, video processing, text processing, and there are 4 different pipelines, right? It is a function of capability. If you have people from different backgrounds, they are capable enough to run it, you can get it done quickly. If you don't have people from different streams, either you have to hire or you have to retrain or provide training and upgradation of skills to those people to get up to speed to take care of those tasks. In those cases, you have to learn, do, and complete the project, which means the project would take time. If it is a simpler project where one simple layer of ML is there, you can complete it quickly. But if your project is expanding, right, and it has larger scope, different kinds of pipes are there, and you have to complete all those things, it will take time. So there is no clear answer how long it would take. It depends on how you have scoped out the project. So it's completely a function of your scoping exercise. Okay.
They
How
would
do
want
you
to know your
patent?
patents, and yeah, they want to know about your patents and books.
Right. How do you patent an AI and ML combination? Uh, may I know the link to your registered patent? Right. See, patent. What is patent? Patent is something which is innovation, right? Which is something different that you are doing. You can only like register or you can only file for a patent when you see problems in the existing process and you are bringing a solution to it, right? So that's how you can propose a system and a method where you are telling that this is the standard system and method how you can solve it. Now that becomes a novelty or new idea. If you are proposing something new, of course, that is patentable. Now to register a patent, of course, there are different patent offices. You have the USPTO, you have Indian Patent Office. I mean, you can hire a lawyer to file your patents. Okay, but you can't patent an algorithm, right? AI algorithms or ML algorithms, you can't patent it. You can patent a solution, you can patent an approach, you can patent an innovative idea, right? How to measure which is right algorithm for my problem statement? Yes. So right algorithm for problem statement, yeah, that's a continuous step-by-step process which takes time. So and there is a chronological order to it. You can start with, let's take a linear regression, and you will look at what are the limitations and advantages of linear regression. From the limitations of this model, you will go to the next model. Now, when you apply the next model, again, what are the merits and limitations of that model? Then again, limitations of that model gives rise to another model. So it's a chain, right? That's how you will get to know if the situation is like this, what kind of a model I would choose. So it's like whole exercise. It takes time to understand the internal working of each models and behavior of each models and the kind of data that is suitable for this kind of algorithm. So it's like it takes time to understand this. There is no clear-cut answer that, okay, this is how you'll identify. No, you have to look at the nuances of the data, the nuances of the problem statement, and what kind of output this algorithm can provide to you. Do we have any standard validation procedures to check the validity of data before starting with modeling? Yes, of course we have. So there is a crisp DM methodology, typically like data mining process, standard data mining process you can follow, right, before proceeding with the modeling step. Data cleaning takes more time than expected. That is true. Absolutely. So 80%, 70 to 80% of your time should go to, or typically it's going towards data cleanup, data restructuring, transformations, make the data available for a trainable model, right? It takes time. Now, if you want to automate that, yes, that's a massive task because here, like every database developer, they store it in a different way. Their schema is different. There is no standard schema, right? It's depending on the convenience. If I am a developer, I will store it the way I want, the way it is. Like that's why there is no standard process. If you have a standard process, you can establish a standard process, then you can automate it. Okay. For BI developer, in which phase can develop? How we can change the career, right? So as a business intelligence developer, like I think the BI, so there is like a business analytics course. So where not into too much like deep learning, machine learning, etc. But you should be able to know what are the basic algorithms and what kind of output and what kind of problems it solves, and what are the answers we can get from data by applying this kind of methodology or systems or processes. So I would say the business analytics career, not into too much into technical roles like machine learning and deep learning, but yes, you can say. Can you give link for your books? Yeah, you can just type in Amazon, you'll get it. All the books are available on Amazon. Okay. Is it necessary to have programming knowledge for a data science engineer? Of course, yes. If you are data science, see, data science, there are different kinds of roles. There are storytellers. There are like visualization experts who prepares the slides, PPTs, etc. And there are engineers. So being a data science engineer, definitely programming knowledge is essential, right? I'm a startup for healthcare on IoT. I have an idea to introduce AIML. Customers are asking to improve health via AIML usage. But in this case, AI and ML, would it be very complex? Right. See, it's there. So the complexity is there in your statement itself. So, right, customers are asking improve health, right? It's a very generic problem statement. Improve health means as means is it like improving cardio fitness? Is it like reducing blood pressure, reducing sugar? So you have to dissect the problem, right? So each of the scenarios, or build muscle mass, like increase the endurance. So what is that? You have to specify. You can't just have like improve health, because all those tracks that helps, that will help you in improving the overall health, right? So you have to dissect. Now, if it is cardio fitness, definitely it's a function of exercise, right? Right, and different activities like jogging, swimming, like different kinds of activities. So, is there any data capture unit here, which gives you the customized information about, let's take how many minutes you are jogging, how many minutes you are swimming, etc., so on and so forth. If you have data, you can build an engine. If you have data engine, then definitely you can give customized recommendations. That's how you can improve the health. But the overall problem statement, you can break it into maybe multiple 5 or 10 different problems.
I would take a quick minute to introduce you to the programs that which we run here under the banner of emerging technologies. One of such programs which we have is a PG diploma, MTech or MSc in artificial intelligence, which you can see on your screen. We say that this is a research based program. That means those who are participating in these programs, who come from various companies with an average experience of about 10 plus years, are looking to improve their not just on a certifications level, but on developing something very useful for themselves or to the commercial purposes or for social problem solving. And all these programs are taught using live industry grade problem solving methods, using the variety of projects, from imaging to text to fuzzy systems to uh, covering various domains, starting from say healthcare to the e-commerce sectors to education, a series of varieties of programs that in terms of projects that which we run. And this is also an AICT UGC approved program, so the validity, the global validity of this program is also very, very high compared to others in the market. Yeah. So this is what Pradeepta told in say 45 minutes. It is to master this. It takes so many years of expertise which Pradeepta and all come bring to the table. So in this 2 years of span of this program, which is spread across say 6 trimesters, mainly with 4 trimesters, with a series of modules being very, very carefully crafted, starting from programming understanding to data handling, both structured and unstructured handling, and then moving on to model building, statistical, both machine learning using deep learning and reinforcement model building, moving on to actually building some expertise in some of these areas, especially NLP based or your fuzzy systems based, and then finally to deploy either through with live data coming from say your live streaming devices, or it could be robotic automations or production and maintenance of AI systems in cloud. All these things gets covered in this 4 trimesters fast track program on artificial intelligence. And we specialize in some of these areas because we have very dedicated infrastructure here. We have a series of mentors, industry mentors, who are practitioners, who are thought leaders like Pradeepta, who is part of the systems in terms of guiding the projects and the participants. So we would appreciate if you can maybe walk down to our campus or connect with our team here, and to know more about any of our programs. We would be glad to connect with you one-on-one. We hope that you could get some of your answers, some of your questions being answered. And we thank on behalf of all the participants, all the attendees, Pradeepta for spending his time and taking actually very, very factful, very informative understanding on the real world challenges while running AI projects. And we So thank you so much, Pradeepta and everyone for being with us today, and look forward to meeting all of you in our next webinar.